Okay, this is a video that looks at synthetic division, which is a quicker way of doing long division for polynomials. But first, let's look at a little bit of a problem that some of us explored the other day. If we have a binomial expansion, I want you to convince yourself that we can write this as from I equals 0 to I equals n. The sum of n choose I times a to the n minus I times b to the I. So this is a way of using sigma notation to expand a binomial. Take a little bit of time. See if does this make sense to you? All right, synthetic division. So we've learned a method of using log division where if you have some linear, or any polynomial rather, going into another polynomial, we look at the leftmost terms and we say x goes into x cubed, 1x squared, and we learned how to do this. So the next term, we'd get 12x squared, and we'd subtract the x, and we'd say that x goes into 12x squared 12x times. So you get 59x plus 11. Okay, so it would go on as such. Using this algorithm, there's a shorthand way of doing this. As long as the leading coefficient on your divisor, so x minus 5, as long as your leading coefficient is 1, so as long as we're talking about x minus a, where in this case a equals 5. So that would be a root. So we can take our root, and here is the coefficients from, this is the same problem. So I'll take my coefficients, and we know that the leading term goes in one time, so this 1 always drops, and then we can say 5 times 1 is 5, and we're just adding these numbers up, so 12, and then 5 times 12 is 60, add them up, 59, and then 5 times 59, well, that gets a little bit bigger now. It's following the same algorithm. You just need to kind of see what that logic is. And so our answer then becomes 1. So here's my answer. My answer is 1x squared plus 12x plus 59 plus, with a remainder of 306, over x minus 5. Now, I'm giving you this shorthand. The fact is, as I said, you can use software to do this most of the time, but to be able to do this quickly by hand will come in useful every once in a while. So just to look at this again, just showing how these are the exact same thing. All right, what if the leading coefficient was not 0? Well, quite frankly, we can just make it become 0. So we could think of dividing by 2x minus 7. So if we think about f of x being divided by 2x minus 7, you could think of it as being divided by 2 times x minus 3.5, which equals f of x over 2 times x minus 3.5. So this, using algebra, is just 1/2 times f of x divided by x minus 3.5. And now that I have it in terms of 3.5, rather, the leading coefficient being 1, now I can use the same model. So I could set up 3.5, and then 4, 6, 9. And we start with, this just starts with 4. So then we have 3.5 times 4, which is 14. And add those up, you get 20. And then 3.5 times 20, well, I don't know. Oh, of course, 70. And add those up, you get 79. So this would equal so what we have is, going back to what we started with, 1/2 times this result, which is 4x plus 20 plus 79 over x minus 3.5. That can simplify even more. That could simplify to 2x plus 10 plus 79 over 2x minus 7. So just to show that synthetic division can work when you're using, when the leading coefficient's not 1. Okay, so we introduced this the other day. This is just a way of thinking about long division. So if you want to, pause this, pause the video, and see if you can get the right solution. And the way you can check to see if you got the right solution is just to put this into Wolfram alpha and see if you get the same result. All right, the remainder theorem, just something important. It's a helpful way for you to think about doing some algebra a little bit faster. So let's say that we divide this function by x minus 3. And so, if we do that, what we're going to get when you take f of x and divide it by x minus 3, this will equal some quotient function plus the remainder function over x minus 3. And if I multiply both sides by x minus 3, what I see is I see the function equals the quotient, so whatever I get when I divide this by the x minus 3, times x minus 3 plus r of x. So what's interesting here is that when I evaluate f of 3, now I'm choosing 3 because that's what I divided by. When I evaluate f of 3, I'm going to get q of 3 times 3 minus 3 plus r of 3. And this is always, because I'm choosing the same x value as my factor, this will always go to 0. So this is always going to simply equal r of 3, which is my function evaluated at 3 is the remainder evaluated at 3 when I divide by x minus 3. This is an interesting result. Let's look at this again. So I'd like for you to take a second, pause the video, try these questions, and ask if you have any questions that come up out of this. Write your solutions down in your notebook. Okay, so here is some additional homework that I would like for you to work on. So I'm asking you to find all of these questions are fairly the same, so you don't feel like you need to do all of them, but find both the quotient and the remainder when you do the following division. And I encourage you to try to use both the long division method but also synthetic division. Here's another question to look at.